Today we're going to look at expressing and interpreting remainders different ways depending on the division problem that we're looking at. Today in this video we're going to use the partial quotients method of division. Again, this is just one method of division, but we're going to use this today during this video. Our first problem is that Adam won 188 candy bars in a raffle. He decided to share them equally with 7 of his classmates and himself. How many candy bars did each person receive? And the first way we can look at this problem is we can draw circles to represent each person. And remember, this is 7 of Adam's friends and himself. So that's 8 people total. And they each share 188 candy bars. So if we were drawing a picture to solve this math problem, we could draw these 8 circles and begin to write in dashes to represent each candy bar that each person is going to receive. And we could keep writing all these dashes until we get to 188. So here we go. Each person is getting 3. Now each person is getting 4. Each person is going to get a 5th. And we're counting all the way up to 188. And now each person gets a 6th. And by this time you're getting quite tired. So am I. So let's choose a different method to solve and draw this picture. In fact, let's go ahead and erase this. Really, this problem is asking us to take 188 candy bars and divide it equally among 8 people. So our math problem becomes 188 divided by 8. So we set up our partial quotients algorithm, dividing 188 divided by 8, and we ask ourselves, what math fact, what multiple of 8 gets us very close to 188? Well, I know that 8 times 2 is 16. So I can just add a 0 behind my 2 to make it 8 times 20, and I know that 8 times 20 is actually 160. I've erased a little bit of 188 here, but again, 8 times 20 is 160. And now I'm going to subtract 188 minus 160. 8 minus 0 is 8. 8 minus 6 is 2. And 1 minus 1 is 0. So my new goal number is 28. So I ask myself, what math fact times 8 gets me close to 28? And I know that 8 times 3 is 24. Again, 28 minus 24. 8 minus 4 is 4. 2 minus 2 is 0. So I'm left with 4. I've got 4 left over. So I come over here, I add up my partial quotients. 20 plus 3 is 23. And I've got 4 left over. But again, remember the original math problem. I was dealing with candy bars. So if each person gets 23 full candy bars, what about these remaining 4 candy bars? Well, because they're candy bars, we can actually split them up into equal pieces. Our remainder becomes the numerator in our solution, and our divisor, 8, becomes the denominator in our solution. So we can see that each person can receive 23 whole candy bars and 4/8 of a candy bar. Or we can write this and simplify our fraction. We can say that each person can receive 23 whole candy bars, and we know that 4 is actually just half of 8. So it's actually 23 and 1/2. 4/8 and 1/2 are the same amount of a candy bar. So each person gets 23 whole candy bars and half of a candy bar because we can split them evenly. So again, going back to our original drawing, now we can save some time. Again, we can draw 8 circles to represent the 8 people who are sharing the candy bars. And instead of counting all the way up to 188 and making tally marks for each person, we can simply show that everybody receives 23 whole candy bars. But they didn't just receive 23 whole candy bars, did they? As we saw, we had a remainder, and we can use that remainder to create a fraction. And every person received 4/8, which is the same as 1/2 of a candy bar as well. So each person It's 23 whole candy bars and a half of a candy bar. Let's take a look at another math problem so we can gain more familiarity with how we interpret remainders. Eve is buying balloons for her party. Balloons cost $6 per bunch. How many bunches can she buy with $75? Again, we're going to use the partial quotients method of division to help us solve this math problem. So the math problem is $75 divided by 6. I'm sorry, $75 divided by 6. So we ask ourselves, what math fact gets us close to 75? We know that 6 times 10 is 60. That gets us close to 75. And we subtract. 75 minus 60 is 15. So we ask ourselves again, what math fact times 6 gets us close to 15? And we know that 6 times 2 is 12. And 12 is close to 15. But we have a difference of 3. 15 minus 12 is 3. So we know that our solution is 12, right? She can buy 12 bunches. 12 bunches of balloons. But what do we do with this remainder 3? Can we have remainder 3 bunches of balloons? Well, like if I drew a picture of a balloon, could I really have a remainder 3? No, I couldn't really have a remainder 3 of bunches. So how many whole bunches can Eve purchase? Well, Eve can only purchase 12 whole bunches. We can't purchase a remainder of a bunch. So I hope that you've gained more familiarity with how do we interpret remainders. Sometimes we just ignore them. Sometimes we represent them as a fraction. And other times we're actually going to add one more and round up, especially when we're dealing with things that can't be split up, like a classroom if you were an architect.